As you can see here, the directions have changed. It now says solve each system by substitution. And the reason we do this is because graphs are pretty limited. If the answer is a decimal, you really don't know where that answer is. If the y value out here is a decimal, it's really hard to get started. I mean, look at this. Starting at 13 on the y-axis and going up 6 over 1, that'd be really hard to graph. So substitution lets us do problems that are messy. So let's see if this is a messy problem or not. What I have is y by itself and y by itself again. That is the perfect situation because it tells me y is equal to these things, which means I can make a substitution in the next problem. I can take y out of this equation and fill it with y's definition. This top is really a definition of what y is. So instead of writing the y, I'm going to write the definition for what y is. That's why it's called the substitution. Y came out of the game, and its equal value replacement took its spot. So I have an equation now which has one variable in it. This has an x over here on this side, and I have an x over here on this side. So I'm down to just one variable now. I can solve this. This is your standard equation. I'm going to move this 5x to the right because I want to keep everything positive. That's going to leave me with 2 equals 11x plus 13. I've already chosen to put my variable here, so now I have to move my constant to the other side, which is done. And now I want to split that 11 away from the x. Now it's time for division. Because I don't want to get rid of the x, I want to leave the x there. What I wanted to get rid of was the 11, that's why I'm dividing. And a negative over a positive is a negative, so I get -1 for the answer. Now, unfortunately, I'm not done with the problem. I've done the hardest part, but I'm not quite done yet because I don't know what the value of y is. But if I go back up to that top equation I had, y is equal to -5x plus 2. And since I know x's name is -1, I can call it by its name. So when I come back up here, I just have to say, if x is -1, replace x with -1. And I'm going to get a very straightforward answer. -5 times -1 is 5. I can add 2 to that, and I have my answer of 7. I now have the answer of x is -1, y is 7. If I write it in coordinate form, it would look like that. I've done everything I have to do. So that was your best case situation. I really liked it because y was by itself. If you look over at the second problem, though, y is by itself in one of the equations, but not in the other one. So my substitution is going to be a little harder to see. I still have an equal value replacement for y. I still know what y is, and I still have to do a substitution. But this is where I want to make physical sense out of it. If you think of this like basketball, there's 5 players on the court for basketball. Player 1, player 2, player 3, player 4, and player 5. The only thing I'm substituting out is player y. That's the player that I'm getting rid of. And I'm replacing that player with this. So when I go back up on my court, I don't take any of the other players out of the court. This player's still there, that player's still there, this player's still there. The only thing that came out of the game was that y. That y came out, and its equal replacement went in its spot. Now I still have the other players on the court all around that. So the 8x stayed the same, the +5 is still there, but instead of y, I put its replacement. The equals 19 is still there. Once I do that, I now have parentheses that I have to deal with, order of operations. So I'm going to use distributive property to get these numbers broken out of those parentheses. So I'll copy the 8x, I'll do the multiplication, I'll do that multiplication, and I'll copy the others. Now that I don't have parentheses anymore, now I can start what I call sorting the laundry. Get all of the x's together, negative 22x. And now I have one unknown, move the constant to the other side. As a final step, I'm going to want to get rid of this coefficient. Again, I'm leaving the x where it is, so I have to use division to break that off. Division is going to separate the number from the letter. And I have the hardest part, which was getting an x value. Now, just like the other problem we did, getting one answer is only the first part of the problem. You still need to get the second part. I have x. I'm going to use my bottom equation to get y. I'm going to copy it down. But I'm going to call x by its name. Now that I know x is equal to negative 2, I don't have to write x anymore. I can put negative 2 in place of x. I know in psychology they talk about calling people by their name. It's more meaningful that way if you name the person. So we're going to name the person. We know its name. X's name is negative 2. So we're going to call it by its name. Now it's a simple subtraction. Yet again, y is 7. It's kind of funny, both of them came out to being 7 for the y value. Complete coincidence, but there it is. Even if both of these started out in this form, you would just have to get y or x by itself in one of the equations. It doesn't matter if y is the one by itself or x is the one by itself. In both of these examples, I gave you problems where y was already by itself. That's why we used it. But in the future, as you're working through these, as long as you can get something by itself, you'll have an equal value replacement, and you'll be able to substitute that into the other equation.